So 1.1's patterns in inductive reasoning. Huh? Not your vocab or your theorem and postulate book. Literally anything else. All right, so we're going to start on number 14. So basically, it's a little bit challenging for me to attempt to copy the pictures out of the book, but I will do my best. We have 3 squares with stuff inside of them that are all supposed to be the same size. They just don't look the same size. And then there's like a square inside of each of them. Well, I guess a diamond, but technically a square. All right, so that's the question, and they want us to figure out what the next picture would look like. So I'm going to create another box over here. Maybe. Okay. So based on this, any ideas what the next one's going to look like? So it started up here and we went around to the right.
So blue would be on the left.
Yep, so blue should be over here. And covering a good chunk of it, and then we'll have 4 lines on this side. And I'm not gonna like get out a thing and measure and make sure it's exact. If we're like doing something with lines, that's a little bit different, but something like this, it's just like give me a rough sketch of what it looks like. I'm not artistically inclined if you can't tell, so don't expect that you are either. Let's see, doing it with number patterns, number 16. It says to describe a pattern in the sequence of numbers, predict the next number. So basically they want us to tell what the next number is and how do we get from one number to the next. So we've got 1, 4, 7, 10, and so on and so forth. You can just say it.
It's plus 3 each time.
Yep, so I'm adding 3 every time to get there. So what's the next number?
13.
Yep, 13. Now, sometimes I may ask you on a quiz or a test, or you may have some problems like this that say, like, tell me the next 3 numbers. So always make sure you pay attention to what the instructions are asking for. This one in particular just says predict the next number. Okay, always make sure you read the instructions. 18. We've got 1, 11, 121, 1,331. How am I getting from one to the next?
11.
Yep, multiply by 11. And the next number, I'll just tell you, 14,641. Now, I don't love you using your calculator, but something like this, I mean, you can just multiply it out on a piece of paper, but I don't mind you grabbing your calculator to multiply 1,331 by 11, because that's just really big, and I don't want you to waste time on something like that, so. 20. 7, 9, 13, 19, 27. Is this one doing the same thing between every set of numbers? So how am I getting from 7 to 9? How about 9 to 13?
It's even numbers all the way up. Which would be plus
So there's different ways to like write this. The book has like some slightly fancier like terminology for how to write it. But basically something like add consecutive multiples of 2 or something like that would be how I would actually explain what's happening. And so what would my next number be? What would I be adding to 27?
10.
Yep,
We
10.
should make it 37.
Yep. Let's do one more because I think this one's a little bit more challenging. We've got 256, 16, or 2.
Oh. Divide by its.
This one's the hardest one for sure.
4. 5 by 12.
Wouldn't you do times 1/4? Or divide by 1/4? No.
So let's skip this first one for a second. How do I get from 16 to 4? How do I get from 4 to 2?
Divide
So divide by 6, divide by 4, divide by 2.
Well, it's 256 divided by 6, 16. I don't think it is.
Oh, it's 8.
It's definitely not 6. So 256 divided by 8 is 32. Are there any other operations besides
16.
division that I can use? So 256 divided by 16 is 16. Let's go this way. 2 times 2 is 4. 4 times 4 is 16. 16 times 16 is 256. So what's the opposite of that? I'm basically squaring a number. So what am I doing to go this way? If I'm squaring going this way, what am I doing when I go this way? What's the opposite of a square?
Wait, square like.
All right, if I had this and I told you to solve for x, what would you do?
2 is reciprocal 2.
That should be 2.
Okay, well it is, but why?
Divide.
2 times 2 is 4.
Okay,
Oh, no,
that's a
'cause-
square. So what is the undoing of a square? I'm trying to find one around the room. I mean, there's one up here. I can't point to it. I can't go up that high, but
Square root.
yes, the square root. So if I take the square root of 256, I get 16. If I take the square root of 16, I get 4. If I take the square root of 4, I get 2. If I take the square root of 2, I get... No. Square root of 2. So, I'm not actually dividing in this case. That's what was helping me figure it out. But I'm actually taking the square root of the numbers. They're not usually quite that challenging, but they can be. 24. This one is a picture. So the first one, it says, the first 3 objects in a pattern are shown. How many blocks are in the next object? So I'm just going to do them as squares and not little blocks, but just know that they're supposed to be little blocks. So if those are my first three pictures, what should the next one look like?
Eight on the bottom, and then 5, and then 3, and 1.
Are you sure it's 8?
7.
7, yeah. So I'll have 7 on the bottom. And then I have 5. And then I have 3. And then I have 1. So how many total blocks are here?
16. No. Yeah, 16.
16. So you don't necessarily have to write out the picture on that one. You could have just like written the numbers because this was 1, this was add 3. Like you could have just added it up, but I just like to draw the picture for the visual. I'm deciding I don't want to do this one. Gonna skip that one. All right, complete the conjecture based on the pattern you observed in the specific cases. So 30, the conjecture is the product of any two numbers, or sorry, any two odd numbers is blank. And they give us some examples. 1 times 1 is 1. 1 times 3 is 3. 3 times 5 is 15. And then they go out. I'm not going to write them all, but 201 times 305 is 61,305. So what do we think fills in this blank?
Odd.
Yep. The product of any two odd numbers is odd. So if I multiply two odd numbers, I'm going to get an odd number. All right, show the conjecture is false by finding a counterexample. So 34. All prime numbers are odd. Well, first of all, is that true? Do we know what a prime number is?
I forgot.
What is it?
It's anything that can be only times is by itself by like 1 to make the number.
Yep. Can only have the like product of itself in 1. So some prime number examples would be like 17, 19, 7. So, anybody know what the first prime number is?
1,
1's not technically prime.
3.
It is prime. Think about the definition of a prime number. It can only be multiplied by 1 in itself.
0.
0, 2.
That's what I said.
Yep. It's got to be 2. Because to get the product of 2, it's 1 times 2. So, our counter example would be that 2 is prime and not odd. Or you could say 2 is prime and even, something like that. 36 says, if the product of two numbers is even, then the first two numbers must be even. So that's saying if I multiply two numbers together and it's even, then the two numbers that I multiply together have to be even. So can you think of an example where that's not the case?
3 and 10.
Yep. 3 and 10 works. So 3 times 10 is, we have an odd and an even, and that's equal to 30, which is even. So we would say this would be our example, and then we would say, but 3 is not even, to explain the why of this. One more of these ones of finding the counterexample. 38, the square root of a number x is always less than x. Can we think of an example where that's not true? So let's just think about it. So what's the square root of 4?
2.
So the square root of a number x is always less than x. So 2 is less than 4, so that's true. So I need a scenario where this is not true. Any ideas?
-4.
Can't take the square root of a negative number. It's imaginary. It's the square root of 1. So is it less than? How about a fraction? Let's make this into a fraction. Let's say the square root of 1/4. So square root rules then tell me that this would be the square root of 1 over the square root of 4. We've already talked about these. What's the square root of 1? What's the square root of 4?
2.
So the square root of a number x, so that would be 1/4, is always less than x. So 1/4 is x. The square root of x is 1/2. Is that true? Is 1/2 less than 1/4?
Yep.
It's greater than, so this would be my counterexample right here. Because 1/2 is greater than 1/4. That would be your reasoning. Questions on those? All right, that's it. So I'm going to give you your problems. We still have about 15 minutes, so you can probably knock this out. Problems are 17, 19, 21, 25, 27, 29, 31, 35, 37, 39, 47, and then a couple review problems for practice, 63, 65, and 67. Now, I want to talk about something real quick about how to set up your paper. Your paper has to be set up this way or I will not take your homework. It's over there on the thing, but we're going to talk about it now. This is going to have your name on it. Okay? I don't require you to put the date. If you want to put the date, that's up to you. Class, okay? So this is geometry, so you're going to write geometry there. You don't have to write the word class. I'm just saying that's what you put there. And then below that, you're going to put the section number. So here you would put that it is 1.1. And if you want to write out the problems on the actual paper, you can do it there. But you have to have these three things. I also will not take paper that has fringes on the side of it. Don't rip it out of a notebook and hand it in with the little frilly things on the side of it. Okay? If you rip it out of your notebook, that's fine, but cut the little things off. Okay? I want a normal piece of paper. Questions? Yes, Taylor. Sure. Any other questions? All right, so you have 15 minutes. You should be able to knock out most of these